burada cədvələ baxsanız, fikir verirsiniz x-in x-in marginal probability mass functionu görürsüz də, Teymur, Muradxan görürsüz. 3-də 1, 3-də 1, 3-də 1, düzdür?
Bəli.
Bu bizim expected value of x-imizi tapırıq. Hər bir value, x-in birinci value'su nədir? -1, düzdür? -1'i hansı ehtimalla götürür? 3-də 1 ehtimalla. So, -1 vurulsun 3-də 1. Üstə gəlinsin. İkinci value'su nədir x-in? 0. 0 hansı ehtimalla götürür? 3-də 1 ehtimalla. 0 vurulsun 3-də 1. Üstə gəlinsin. Next value nədir? Next value 1'dir. X 1'i hansı ehtimalla götürür? 3'də 1 ehtimalla.
Aha, onu bildim, onu başa düşdüm. Üçüncü hissəyə yazmısınız, expected value x times y.
Aha. Burada necə edirsiniz? Tamam. Burada biz istifadə edirik joint probability-dən də. Çünki expected value of x, y tapmaq üçün nə edirsiniz? X vurulsun y vurulsun joint probability density. Probability mass function. Bu içəridə olan bu yaşıl şeylər, bunlar hamısı jointdir, düzdür? Bu nə deməkdir? 0 nə deməkdir? 0 o deməkdir ki, the probability that x is -1 and y is 0 is actually 0, right?
Başa düşdüm.
The probability that x is 0 and y is 0 is 1/3. Görürsünüz bu içəridəkilər jointdir. It's actually the joint probability mass function. Onu necə edirsiniz? If the expectation concerns two variables, concerns the function of two variables, you have to scale it by the joint probability mass function, not with marginal probability mass function. Understand?
Aha, başa düşdüm.
So here you have first value of, like, what is the probability of -1 0? It's 0. What was the probability that x is -1, y is 0? It's 0. So 0 -1 times 0, bu nə deməkdir? X vurulsun y-dır. X -1'dir, y 0'dır. Ehtimalı nədir? Bu joint eventin probability nədir? 0'dır. Vururuq 0'a, üstə gəlməsin. X 0'dır, y 0'dır. Ehtimalı nə qədərdir? 3-də 1. 0, 0 buradadır. Ehtimalı 3-də 1'dir. 0 vur 0 vurulsun 3-də 1 ehtimalla. Düzdür? Sonra. The same goes for all. Next value. Probability x 1'dir, y 0'dır. 1 vurulsun 0, eləyəcək 0. Onun ehtimalı nədir? 0. 1, 0, 0. O da 0 verəcək. Növbəti value nədir? X 1'dir, y -1'dir. Ucu keçdi bura. X 1, daha doğrusu x -1'dir, y 1'dir. Ehtimalı nədir? 3-də 1. 3-də 1 vurulsun, 1 vur -1. Üstə gəlinsin. Növbəti value nədir? X 0'dır, y 1'dir. 0 vur 1 vurulsun 0. Üstə gəl. Başa düşdünüz də?
Bəli, başa düşdüm.
Yəni ki, whenever the expectation, remember that, whenever expectation of some function concerns two variables simultaneously, okay, you have to multiply, you have to weight it by the joint probability. Yəni bunu siz şeylə eləyə bilməzsiniz. Marginal probability məsələn eləmək mümkün deyil. Çünki marginal ancaq x-ə aiddir. Y haqqında heç bir məlumat vermir. Düzdür? Bu x haqqındadır. Bunun üzəsində.
Mənim bir də homework'da 2 dənə sual var idi. İkisi də lecture, daha doğrusu homework 3-dəki sualı idi, bir dənəsi. Təkrarlanıb elə bil, eyni sualdır. Onu yazmaq lazımdır, yəni necə?
Yazın, problem yoxdur da. İndi sualdırsa sualı yazmaq lazımdır. Bu hissəni başa düşdünüz? Example 8.
Hə, başa düşdüm onu. Yəni eyni sualdır, 2 dəfə təkrarlanıb hətta.
Tamam,
yəni
problem yoxdur, no problem. Yazın.
Hə.
Okay. Təkrar
onda homework 4-də məsələn nömrə 1 sualla nömrə 4-də eynidir. 11-ni yazsaq olar bəs. Yəni
onda yaza bilərsiniz ki, 4 the same as question 1. Bunu yazırsınız qurtardı. Okay. Başqa sual var?
Burdan yox.
Məndə var.
Buyurun Teymur.
Deməli belə moment generating functions biz eləyəndə birinci expectation of e to the power of tx tapırıq, düzdür?
Düz. Siz bəlkə example üzərindən deyərsiniz ki, məsələn hansı
example indi deyərəm bir dəqiqə. Prosta orada belə sualdır ki, yəni soruşmaq istəyirdim. Onu belə eləyirik, onda biz e to the power of tx multiplied by pdf of e to the power of tx tapmalıyıq. Düzdür?
Sure.
Bəs lecture-da siz yazmışdınız ki e to the power of tx multiplied by pdf of x.
Yeah, PDF of X. That is how it should be. Yes. Belə olmalıdır. Siz konkret example üzərindən deyə bilərsiniz mi?
Hı hı.
Is it about fourth lecture or third lecture?
No, lecture 2'de. Lecture 2.
Lecture 2.
Example 11. 11.
Of lecture 2, right?
Yes.
Of lecture 2. Let me find lecture 2. Lecture 2. Example 11. Just a second. Example 11. Okay, you are talking about this example, right?
Yes.
Okay. Here you have the probability density of x, right? Which is e to power minus x. Agree?
Yes.
Where x is in between 0 and positive infinity, isn't it? Now you are searching for these. Yes, moment generating function. Moment generating function is actually the expectation of this function, isn't it?
Yes.
Screen'i görebilirsiniz Temur.
Bəli.
So, nəinki expectation'ını axtarırsınızsa, həmin şeyi aparıb qoyursunuz summation sign-ın altına. Yəni burada continuous olduğuna görə burada artıq integralın altına qoymalıyıq. Aparıb qoyuruq. Bax bunun biz e to power tx-in expectation axtarırıq. Ona görə də we have to put it under the integral sign. Make sense? And multiply
Yes.
by the PDF. Because this is how you find the expectation of the function. If you want to find the expectation of something, yes, you put that under the integral sign and multiply by the respective PDF, and that's all.
I was thinking that, for example, if we find expectation of x, then yes, we multiply x by PDF of x. But if we look for expectation of e to the tx, don't we have to multiply it by PDF of e to the power of tx?
Yes. Here I understand what you mean. Yes, but the thing is that e to power tx is actually a function of x. We had this rule. Just a second. We had this rule in lecture 2. Whenever it's, I mean, you can do that, but in that case, what you have to do, you can do that in this way, no problem. But in that case, you have to find the the PDF of each PDF of the function itself. Onun üçün də yerə transformation istifadə edirsiniz. Amma you don't need that because e to power tx is the function of x and you know the x is PDF, that is all. You don't need to do any additional task.
O həmişə belədir, yoxsa?
It's always
Sometimes.
like that. Yes, it's always like that. Whenever you have the we had that rule. Let me find that rule. It's somewhere here. Just a second. Discrete random variables. Where's that random variables? Okay, it should be somewhere here. Where is that expectation thing? Okay. Okay, this is here. Temur. Burada ekranı yaxşı görə bilirsiniz indi.
Bəli.
Baxın. The expectation of a random variable x is defined as this. Agree? It's great.
Yes.
Suppose you have a function y. Yeah, you have a y, which is actually a function of x. Görürsünüz? Gx.
Bəli.
Now you are trying to find the expectation of this function. Actually, y is nothing but gx itself. Onu inirik, aparıb qoyuruq expectation integralın altına, and we are multiplying by the PDF of x because
Okay.
this is it's the function of x itself. But you are right. You can do it in another way. If you know the PDF of gx, no worries. Find the PDF
But
of
it's
gx.
hard to find it, right?
I mean, yes, it's additional task. You can do that. Like find the PDF of gx, which is you have to use this transformation. Use transformation to find the PDF of gx, which is not so easy. Sometimes it's not easy because it might happen that you don't have. You see here we have some monotonicity and so on and so forth. We have a bunch of conditions on the function. For transformation, you need some regularity conditions. Well, bazen it's not sometimes it's not straightforward to find the g-axis PDF. But what you're saying is completely legitimate thing, and
Okay,
that's a good
understand.
intuition. I approve that. Very nice. Great.
Okay. Also, I have one more question about transformation.
Yeah, please.
So first, like when we find the transformation, often we like find the PDF, right? PDF of y, for example. Like
Yes.
sometimes we need to find the CDF of y. How can we like turn PDF into CDF? I don't understand this.
Okay. You have like two major um, transformation techniques. One is called CDF to CDF. It's some kind of it's actually mapping. It's called mapping. So if you have CDF of X here, you can easily convert it to CDF of Y. You can easily find it from it, given that you know this function, given the map from X to Y. Okay. So how you do that? You start with let me see where example 7 is. Okay, there are two techniques. Remember that. What is it? Okay, you see here, Tamer, we have this is actually X. This is supposed to be X. Sometimes when I'm writing, it's ben X yazıram burada ama board'a düşür FY kimi. Burada aslında X'tir. Fx CDF'i beraberdir buna, okay? And we are searching for FYY. So what is FYY CDF? It's actually probability of y less than y, and you are replacing y. You are actually replacing with y with x squared. Unfortunately, there is a problem here. So you are replacing y with x squared. Again, I'm writing correctly, but sometimes it's not
Yeah,
giving it correctly.
I understand.
Okay, and then x, this probability is the same thing as probability that x is in between minus square root of y and positive square root of y. So burada ne yazacağız? Bilirik ki when you are trying to find this kind of probability, evaluate the CDF at the upper bound minus the CDF at the lower bound. But the problem is that for negative values, this is actually x's CDF again. So for negative values, it's actually 0. So this guy gets 0, this guy gets square root of y to power 2, which gives you y. So bu birinci texnikadır. İkinci texnika ise it's PDF to PDF. You know PDF of x and you want to get the PDF of y. So these are two different things actually. Okay, two different methods. Baxın burada yazmışam mən burada. Deyirəm ki, əgər siz FX-in PDF-ini bilirsinizsə, CDF-ini taparıq ondan. CDF to CDF eləyə bilərsiniz. Sonra da CDF-dən də PDF-i tapa bilərsiniz. It's straightforward. So what is the question that you don't know how to get the PDF from CDF? That is the question.
No, I actually wanted how do we find CDF if we have PDF?
Yeah, okay. So if you know the PDF, what you're gonna do? You can do like in many ways actually. Suppose you know table, you know the PDF of X. Find the CDF of X, and then find the CDF of Y. This is one way. Huh? Just do it. The second way is this. You know the CDF of X, find the CDF of, you know the PDF of X, find the PDF of Y. It's straightforward, right? And then integrate PDF of Y to get the CDF of Y. That's all. Yani burada transformation istifadə edə bilərik. Baxın, X-i bilirsiniz. F of X-i, balaca F of X-i, you know the like lowercase f of X. You can use transformation to get f of Y, right?
Yes.
And then by integrating f of y, you can get capital F of y, CDF. Okay? Makes sense?
Yes.
So that's all. I mean, it's easy. But good that I take a look at these lecture notes because sometimes when I'm writing fx, the board shows it as fy. Maybe I have to change my notation to z and x so that it's more understandable.
Is it lecture notes of lecture 2?
Yeah, they are uploaded actually. They are uploaded to the Blackboard.
in the solutions folder, right?
Yeah, in the solutions folder you can find
Okay.
it.
I see.
It's really unfortunate that you see here, for example, I wrote x to power 4. It gave me something, it showed something strange, and here it's actually x to power 4, but it shows it as y to power 4. It kind of truncates this part of x. I don't know why. Good that I took a look at this actually. Yeah.
Okay.
Here also the same goes on. You see, I wrote
Yeah.
ln x to power minus 4. It shows it as ln y to power minus 4. I don't know why. It's the problem with the board itself.
So I just have one question
Yes,
about
please.
CDF. Let's say we have probability density function, intervals between 0, 1, 1, 3, 3, 4, and then infinity.
Uh-huh.
Uh, and when we find, let's say, when CDF of when it is less than 3.
Uh-huh.
So in this case, we will add these values. Yes, integral between 0, 1, 1, 3.
Yes.
We will not 3, but we will write y. 1 y from 1 to y.
Yeah, you have to integrate the PDF over the interval that is defined. Yes, only over the
Okay.
interval that is defined. Maybe I have to show some example if there is. Is there an example that you want me to solve? You could do it.
No, actually, we had it on the homework, and I solved it like that.
Yeah, you should do it. You should do it over all the intervals and pay attention to the fact that whether the when you are taking the integral, don't forget about the intervals of x.
Okay.
Başa düştün ne demek istiyorsun? You have like truncated intervals where x is where PDF is non-zero. So you have to sum over all the cases where PDF is non-zero actually, because there is no sense to integrate in the areas where fx is zero. I mean PDF is zero. There is no sense, right?
Yeah.
Usually you are writing it in this way, like when you are doing. Let me see whether it is given here, PDF and CDF relationship. Okay, so here you do it in this way. You see, you write instead of x, Murat, instead of x, you write some t, which can be some specific value of x. Okay, you write t, and then you integrate from minus and to up to that particular x, and so that once you integrate this out, you are evaluating the upper bound at the x value. So this is the CDF becomes the function of x itself. Okay, this is how we do it. Usually we write some possible value of x here. Instead of x, we write like t or something else to get the
Yeah.
function. Otherwise, you cannot get the function. If you have x here, then it's not going to be a function if these guys are numbers. Bunları siz birinci hissədə keçmişdiniz də, düzdür? PDF'dən how
Ben,
to get CDF
ben
and integration and things like that. It should be straightforward.
I have one more question.
Yes, please.
So when we like do transformation, we find like inverse of y, and like after we solve it, we have to like find the interval of y, right? So we have like interval of x, for example, from 0 to 1,
Yes.
and when we have to transform it, so y is between something and something,
Yes,
right?
yes, sure.
How do we turn the x's interval into y's interval?
You mean something like this, right? Just a minute. You mean some example like this.
Yeah, just an example that you solved. If you look, you did
Okay.
it, but I didn't understand how you found it.
Yeah, just a minute. You just use the function that maps. See, mm, let me see where it is. Can we find some example?
It's in lecture 2, I think.
It's in lecture 2. Let me.
Yes, if I'm not mistaken.
Yeah. Okay, lecture 2. We can give this example, for example. Yeah.
Yeah, yes, this one.
Uh, so
So you found like the if you look a little bit above, you found like PDF of y, and then you showed like in some interval of y, like
yeah, you see how do you find that? Look,
yes. How did you know from 0
y
to infinity?
is equal to what? Y is equal to minus ln x to the power 4. Agree?
Yes.
So x takes after we found the PDF, we know that the PDF is going to be something like this: e to the power minus y. It's great, but what is the interval of y? You have to look at the interval of x. So x is running from 0 to 1, right? So if x goes for, suppose x is exactly equal to 1, what will happen to y here?
Uh,
ln of 1 to power 4 is ln of 1, right? So what does it give
yes.
you? What is ln of 1?
0.
It's 0, right? So it means that once x touches 1, I mean, gets arbitrarily close to 1, y is going to get 0. Agree?
Yes.
So now let's look at the lower boundary. Now indi aşağı boundary'sine bakalım. X eğer 0 olarsa, ln 0 ne olar?
Not defined.
It's going to be minus infinity actually in the limit, isn't it?
All right. Yeah. Minus
Right?
infinity.
So minus infinity, burada da bir tane minus var. Minus infinity ne verir size?
Plus infinity.
Plus infinity. So it means that when x moves within 0, 1 interval, y is actually moving from 0 to positive infinity. Agree?
So we plug the
Yeah.
values of x
Yeah,
into the
sure, sure,
y.
sure. This is how
Oh
you
yeah.
do that.
Okay. Understand.
So
Yeah.
y
Yeah.
is
Understand.
actually between 0 and 1, positive. In some cases, you might have like in lecture 4, I guess we got, or in 3, we got like divided case where it was a little bit complicated. But still, the idea is the same. You are basically looking at the x's interval using the map from x to y, yes? So y is actually a function of x. It's actually a map from x to y. So you are basically plugging the upper boundary, lower boundary, and finding where y is going to be. Uh, yeah, that is how you do that.
Yep. I understand.
Great. Any other question?
No, I don't have.
Yeah, yeah. It's yeah. Please,
Actually, I have question,
yes, please.
but it's not actually about our classes. It's about calculus. I couldn't find the integration.
Mhm.
But it's about integration by parts. I
Yeah.
need to use it to find the expected value. So we have x times, um, let's say some number 5 divided by e to the power 5 times x. So we
Okay.
need to integrate with respect to x between 0 and infinity.
Yeah, yeah, yeah.
And I couldn't actually find it.
So is it in the homework or what? I didn't get it.
Yes, in the homework, we need to find the expected value. And I found, let's say, marginal distribution of x, and then I found expected value of x. But I need to use integration by parts to
So it is.
integrate.
Yeah, yeah. It's actually it should not be complicated, but it's sometimes it's
Yeah, I solved it, but then I checked it on the internet with integral calculator. I get different results, and I did it many times. But
so tell me what was the integral?
okay, x times
So integral from where to where?
0 infinity.
Zero from 0 to infinity. Okay.
Yes, x times
Uh-huh.
let's say a is a number, a divided by
So give me some number. Is there any number or not?
okay, it's not a number, a is a fixed number,
Okay,
but
let's say 5. Yes.
okay,
5x. Okay.
5x divided by e to the power 5x.
E to the power of 5x. But it's there should be some negative value here, isn't it? Yes,
Uh,
it's actually the same. It's actually saying that 5x times e to power minus 5,
minus 6.
isn't it?
Yes, you can write it like
So it's the same. Okay, so what?
that. That's it. Dx.
Yes. Yeah. So this is it actually gets from the rule of, you can get this from the derivative, because when you know that the derivative of the product is actually found by, you know, the first derivative of the first guy times the second guy and so on and so forth. So you got,
Yes.
so I got 0 here on the second part, 1 over 5. So you get 1 over a, you can say 1 over
Yes.
a. This is the solution.
Can I just screenshot it?
Yeah, sure. I can send it to you. Where I share it. Yes. Uh, how do I share it?
You just scroll up. I will screenshot it. You don't need to send it.
No, no, no. I will share it. No worries. Let me copy it. Let me copy and send it to you. Yeah, yeah. It's unfortunately I cannot write it in my board now. I have to pay for the board. But the idea is
No
you
problem.
get it from, you get this formula from the product, the derivative of the product. Okay.
Yeah, I did it with this way. Probably I have made a mistake.
Yeah.
That's why I was getting different answer.
You just take the function. If you take the derivative of the function, it's basically the first part's integral derivative times the second, and so on and so forth. Then you are taking the integral of both sides. You get this kind of formula. And here you are supposing that x is equal to u, yeah, and 5 times e to power minus x is equal to, this part, the second part, e to power minus 5x is equal to v. Okay.
Yeah, I didn't integrate the first part. First part. That's why in my answer I had x.
Yeah.
It should be 0.
Yeah.
Oh, okay, and I don't have any question.
Okay. So here probably the constant. Let me see here. Uh, Here this is the constant. You see, it's the function itself. This part is taken as being the uv, right? And then it's taking the integral of this part.
Yeah.
Because
Yes.
v is this part, yes. And when you are taking the integral of u part, it's kind of 5x. It gives you some constant that drops from this. Maybe sometimes there is a mistake in these solutions, but anyway. Any other question? Any other problem?
I don't. I don't know.
Is this our last online meeting before the midterm, or we'll have more?
Uh, I don't know. This is a difficult question because I don't know when I will be able to come back. Yeah.